All right, this is the third video for direct variation. We have a lot to go through, so we're gonna get started right away. First thing, our problem, this is just a little review. Students in a science class recorded lengths of a stretched string as shown in the table. Determine if each statement is true or false. So first we're gonna determine if the relationship represented over here has a constant rate of change. So if we were to find the constant rate of change, we need to find that the change between all of these. So 0 to 12, I'm changing by 12. And then here I have 18, 24, and 18, 2, 3, 4, and 3. And then I have to put the change of the y over the change of the x. And if that equals the change of the y over the change in this x, it is linear. So here, 12 over 2 is 6, 18 over 3 is 6. Well, 24 divided by 4 is 6, and 18 divided by 3 is 6. They are all 6. So this would be true. Also, 6 grams per centimeter, well, this reduces down to grams per centimeter. So that would be true. The next asks if the equation that represents this relationship would be trying to do one more thing at once. Y equals x plus 10, meaning if I add 10 to any x, I should get my y. Well, 0 plus 10, this would be 0, or this would be 10, not 0. So this one does not work. 2 plus 10 equals 12. That would work. 5 plus 10 does not equal 30, so this would not work. 9 plus 10 would be 19, not 54. So these 4 do not work. The only one that it works for is this one. So this would be false. We do know that in direct variation, and when we have a point 0, 0, we have y equals mx. Well, m we figured out was 6, so our equation would be y equals 6x. Every time I'm going to multiply my x by 6, and I should get my y. 0 times 6 is 0. 2 times 6 is 12. So that works. I should maybe check mark it. That works, and that works. 5 times 6 is 30. That works. 9 times 6 is 54. They all work. Okay, so that's a little review. Now we're going to be working with, we're going to do a review of our when we have a word problem. Again, remember y varies directly with x. So in our word problem, after we read it and it says the distance varies directly with the time, that means the first one is y and our second one is x. So any of the y's, the distance, I highlighted in green, and the time I highlighted in blue. I can choose either one, but here, 2 minutes after a skydiver opens his parachute, he has descended 1,990 feet, or 1,900 feet. Those two numbers go together. Same with 5 minutes and 4,750 feet. So if I go and I write an ordered pair, 5 minutes, I would go down 4,750 feet. And then I can find out the rate. If they're asking for the rate, that is going to be my m. Well, m is y divided by x, which is 4,750. It's getting a little messy. Divided by 5, and that gets me a negative 950, which means 950 feet and per minute. So every 1 minute, they fall 950 feet. Okay, we're going to go one step further, and now we're going to be graphing them. Graphing direct variation equations, remember we have x, y, making a table, first you need to make a table of 4 coordinates. So you're going to choose numbers. I would choose like 0, 1, 2, 3. Sometimes you can add 4 in there if 0. But I would pick 4. If you have the m or the slope is a fraction, you're going to pick numbers that can be divisible by the denominator. So if I have a fraction of 2, I would pick numbers like 2, 4, 6, 8. If I have a denominator of 3, I would pick all these numbers here. 3, 6, 9. These can all be divided by 3. Okay, then you're going to graph the points on the coordinate plane and connect it with a ray. Make sure to title and label the axis of the graph for the word problems. And that's usually honestly what I do. First, I label right away. So, first things first, we need to label our graph. Okay, a cyclist can ride 3 miles in 0.25 hours. So assume that the cyclist biked into miles. Y. It gives you that miles is our y, and it says varies directly with the time in hours, and it tells us that our hours is going to represent our x, or our x is going to represent our hours. So here we do know that it will go through 0, 0 because it says it will varies directly. The situation can be represented by y equals 12x. If we would have taken this and done 3 divided by 0.25, we should have gotten 12. Okay, graph the equation and how far can the cyclist ride per hour. So we need, I like to write label first. So my whole label would be, or my graph label would be cyclist rate. I think I'm spelling that wrong, aren't I? I did. Let's just see. Cyclist rate. Remember, this is our x, and our x is hours. So this is going to be time, and it's in hours. Okay, over here is going to be our distance, and it's going to be in miles. All right, so I'm going to pick some points. Because our slope is 12, I can pick nice, easy numbers, and I'm going to solve. So 12 times 0 is 0. So my x is 0, my y is 0. I'm going to put points. I'm going to make notches here, and each one has to be the same distance between them. So 0, 0, and I'm going to go, this would be 1. So 1 hour. This represents 2 hours, 3 hours, and so forth. This is going to represent, I'm going to put notches here, and it's going to represent the miles. Okay, so y equals, in 1 hour, I would go 12 miles. So I'm going to write miles here. This has to go the same amount. So up to, or over to 2, oh, I'm not there yet. Y equals 12 times 2 would be 24. So up to and up to 24. And if I look, 12, I go up another 12, I get to 24. Go up another 12, I should get to 36. So my next, I should be able to look ahead and see 12 times 3 should be 36. And I am correct. 12 times 3 is 36. If I want to know my rate, cyclist ride per hour, well, in 1 hour, I'm going 12 miles. So 12 miles per hour. All right, let's try to get one more in here. A grocery store sells 6 oranges for $2. Assume that the cost of the oranges, so that's going to be my y, varies directly with the number of oranges. So I started here. My number of oranges is going to be my x, so it's going to go on my x-axis. So the number, my y-axis is going to be the cost of oranges. my whole label, label it could be a grocery store. It's a terrible writing. Here it gives us this the direct variation equation right here, or 1/3 x. Well, here I have a fraction. So I want to put my my x's. I want to choose ones that can be divided by 3. So divisible by 3. 3 can be, 6 can be, and 9 can be. So 0 y equals 1/3 x. So 1/3 times 0 is just 0. Okay, 1/3 times 3. So 1 times 3 on top, 3 times 1 on the bottom. Oh, so 3 divided by 3 is 1. So I'm going to go over to 3 and up to 1, and I should be right there. 6 1/3 times 6. 1 times 6 on top, 3 on the bottom. 6 divided by 3 is 2. So over to 6 and up to 2. Okay, 9 times 1/3. 9 times 1. So I'm going to get 3. Go over to 9 and up to 3. So what this means is I can buy 3 oranges for $1, 6 oranges for $2, and that's what it told us. It should have, and I could have checked my my math there too. 9 oranges for $3. Okay, I can buy, 7 oranges, but it's going to be a decimal. It's going to be part of a whole fraction. It's going to be 7/3, right? And that it's not going to be nice and easy to graph. So that's why we're going to want to pick those whole numbers. All right, last thing, comparing direct variation equations, comparing the slopes. The steeper the slope. All right, so comparing slopes, the steeper the slope, the faster the rise of the graph. So the distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35x. The distance covered by a grizzly bear is shown on the graph. Which animal is faster? So over here, 35x would be that rate per miles covered per hour. Well, over here, so that's 35 for the rabbit. And the bear is, if I look here, I have 30 miles in 1 hour or 60 miles in 2 hours. Well, what would this would be 35 miles per hour. And this bear would be 30 over 1 or 30 miles per hour. So which one's faster? Well, the rabbit is faster. Which one? We are not going to get to the next example. So I'm just going to go right here. Your assignment is page 195, 3, 12, 15, 17, and 18. If you want, I can go over this one in class.